In this video, we're going to solve part A of question 12. In this part, we want to calculate the integral of cosine square root x dx by using appropriate substitution. So first, let's look at the integral here. It says that we don't have too many options for the substitutions. One way is to let u equal to cosine square root x, and another one is to let u equal to square root of x. But if u is equal to cosine of square root x, then its derivative will be too much complicated, such that it won't help to simplify the integral. Therefore, what I'm gonna use is u equal to square root x. Okay. So now let u equals to square root x. Then its derivative du dx is going to be 1 over 2 square root x. But now square root x is u, so this is also equals to 1 over 2u. Therefore, 2u times du is equal to dx. Okay. Therefore, the integral of cosine square root x dx is equal to, now we make the change of variable, so it is equal to the integral of cosine u times 2u du. Taking out a constant and move u to the front to the front of cosine u here. Okay. Now this integral looks familiar, and actually we have already calculated it when we learned the integration by part, right? Because we cannot make the substitution here since the u is not the derivative of cosine u and vice versa. So what we are going to do now is to identify how to use the integration by part. So normally we will let cosine u equals to the derivative of some new variable. Let's call it v. So we will make cosine u equal to dv du. And this part here, u, I will give it a new name. So I will call it w. So the formula for the integration by parts tells us that it is equal to v times w minus the integral of v times dw du. Okay. So now what we need to do is to find out what's v and dw du are. Okay. Let me calculate them on the right. So now v is a function such that du dv is equal to cosine u. And we already know that the derivative of sine is equal to cosine. So we can let v equal to sine u. That will make the integration by part works. Okay, then what about dw du? dw du is just 1 because w is equal to u. Okay, that's simple. Alright, and then we plug in u, w, dw du into the formula. What we get will be u times sine u minus the integral of v, which is sine u, times dw du, which is 1, and we just ignore that. So it's an integral of sine u du. Okay, so it is equal to, and then we plug in, and then we replace u with square root x. So this becomes square root x sine square root x And then minus the antiderivative, sorry. Let's first calculate the integral of sine u. So we leave the first part the same. So it is equal to u times sine u minus the antiderivative of u, which is negative cosine u plus some constant c. So it is equal to u times sine u plus cosine u minus the constant c. Oh, sorry, I missed the 2 here. So 2 times this guy equal to 2 times this guy. So 2 here. So it should be 2u times sine u plus 2 cosine u minus 2c. Okay. But minus 2c is just equal to plus negative 2c, which is still a constant. So we can still write it as 2u sine u plus 2 cosine u plus some constant c. And we can use the same notation because it doesn't cause the problem here. Okay, so this is the first part. So this is part A of question 12.